Hello everyone, welcome back to the channel. So in the previous session, I have discussed about enzyme catalysis, okay, characteristics of enzyme catalysis, and even we considered the mechanism of a enzyme catalysis. So with that, that catalysis concept is completed. Okay. Well, we just recall the last bit. What is that? Mechanism of a enzyme catalysis. Naveen Hedidevi? Yes. All enzyme catalysis, okay, in all enzyme catalysis, yes, what happens, the okay, all reactant molecules we used to call substrate molecules, they are going to occupy the active centers present on the enzyme surface. So there will be formation of a temporary bond or interaction between enzyme and substrate, so which leads to formation of a enzyme substrate complex. Okay, so the first step, according to the mechanism, what I can say, the enzyme catalysis involves two steps. In the first step, what happens, the all reactant molecules, or I can say substrate molecules, are going to interact with the enzyme to form an intermediate complex. What is that? Enzyme substrate complex. Okay, well, after that formation of enzyme substrate complex, what happens, those reactant molecules come very close to one another so that they interact with themselves. ಏನಾಗುತ್ತೆ ಅಲ್ಲಿ, once they are, it comes in contact with the enzyme, what happens, the reactant molecules come very close enough so that they interact among themselves, which leads to formation of a product. It means what happens, that enzyme substrate complex undergo dissociation, or it undergo decomposition to give product molecules. So the second step, as per the mechanism, second step will be formation of product. So, or else I can say the dissociation of enzyme substrate complex to give product, and enzyme is regenerated. So overall, what we said, if I consider mechanism of enzyme catalysis, yes, it simply follows a lock and key hypothesis. So according to that, first what happens, enzyme reacts with substrate to give enzyme substrate complex. First step. Second step, the enzyme substrate complex decomposes to give product, and enzyme is get regenerated. Okay, well, with that, the second part of the chapter is completed. So the first part, what we said, adsorption concept, and the second part is catalysis. Okay, we completed the two part. Now in this session, I'm going to begin the third part of the chapter. What is that? The third part of the chapter, that is colloids. Okay, ಅಂದ್ರೆ ಈ ಚಾಪ್ಟರ್ ಅಲ್ಲಿ ಮೂರು ಪಾರ್ಟ್ಸ್ ಇದೆ ಅಂತ ಹೇಳಿದ್ದೆ ನಾನು, ಹೌದಾ? Adsorption, second part is catalysis, and the third part is colloids. Well, here we try to get the meaning of a colloids. Yes, what is colloid? So actually the word colloid, the term colloid, which is derived from a Greek word. Greek word ಅಲ್ಲಿ ಏನು ಹೇಳುತ್ತೆ, say col, COL ಅನ್ನೋದನ್ನ ಹೈಲೈಟ್ ಮಾಡ್ತಿದೀವಿ ಇಲ್ಲಿ. Okay, so what is, according to in Greek words, colla, KOLLA, this colla means glue. Okay, glue ಅಂದ್ರೆ ನಮ್ಗೆ ಗೊತ್ತಿದೆ, ಅಂದ್ರೆ ಏನು ಹೇಳ್ತೀವಿ ನಾವು, glue is nothing but a adhesive. Okay, adhesive substance, adhesive material. Okay, ಅಂಟು ಅಂತ ಏನು ಕರಿತೀವಲ್ಲ ನಾವು, ಕೊಲ್ಲಾ, ಗ್ರೀಕ್ ಅಲ್ಲಿ ಏನು, ಗ್ರೀಕ್ ವರ್ಡ್ ಕೊಲ್ಲಾ, ವಿಚ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಗ್ಲೂ. ಸೊ ಇಲ್ಲಿ ಕೊಲಾಯ್ಡ್ ಅಂತ ಹೇಳ್ತೀವ, ಸೊ ಕೊಲ್ಲಾ ಅಂತ ಬರುತ್ತೆ, COLL ಏನ್ ಬರ್ತಾ ಇದೆ ವರ್ಡ್ ಅಲ್ಲಿ, ಈ ನೇಮ್ ಅಲ್ಲಿ, ಇನ್ ದ ನೇಮ್ ಆಫ್ ಕೊಲೈಡ್, yes, we are getting a word colla, COLL. So actually that colla meaning in Greek, this colla means a glue. Okay, well, further, so colloids, for an entire word, or I can say complete word, is a colloid, right? So here IODOS. Okay, ಈಗ ಇಲ್ಲಿ iodose. Okay, iodose ಅಂತ ಹೇಳ್ತೀವಿ. So iodose, which means like, ಅಂದ್ರೆ ಓವರ್ ಆಲ್ ಏನಾಯ್ತು here, collide means what is the word, so glue like substances, ಹೌದಾ? Colla means a Greek word which is originated from a Greek word. So colla, ಏನು ಹೇಳಿದೆ ನಾನು, colla which means glue. Okay, and iodose, which is nothing but like. So the entire word, so as we are seeing collide, Colloid andre ಏನರ್ಥ? It is a glue like a substance. Okay, glue like a substance. So I hope you got the meaning of that. Colloid is nothing but, so what is to be remembered here? Yes, colloids are nothing but they are a glue like a substances. Well, we get the actual meaning of a colloid. See here, when you look at the particles, whatever the animation we are looking at, is these particles, okay, they are falling from top to bottom. They are indicating colloidal particles, okay. Well, so now if I consider colloid is not a substance. ಅಂದ್ರೆ ನಾವು ಬೇಸಿಕಲಿ ಏನು ಹೇಳ್ತಿದೀವಿ ಇಲ್ಲಿ, colloid is not a substance. ಅಂದ್ರೆ ಏನದು ಬರುತ್ತೆ? So colloid is not a substance. So colloid is not a substance, but it is a state of substance which depends upon, which depends on what? Which depends on the molecular size. ಅಂದ್ರೆ colloid ಏನು ಹೇಳ್ತೀವಿ ನಾವು? Colloid is not a substance, but it is a state of substance which depends upon the molecular size. ಈಗ ನಾವು colloid ಅನ್ನು ಹೇಗೆ ಡಿಫೈನ್ ಮಾಡ್ತಿದ್ದೀವಿ? It is not a state of substance. Rather, we are going to define the colloidals based on their size. Okay, molecular size. Well, then what is the molecular size? Okay, what would be the molecular size of a colloids? The colloid size ಎಷ್ಟಿರಬಹುದು ಅಂದ್ರೆ, yes, it is in the range of, okay, what is the range of the particle size here? It is in the range of 10 raised to minus 9 meter to 10 raised to minus 6 meter. Andre here, if the particle size is in the range of 10 raised to minus 9 meter to 10 raised to minus 6 meter, then such type of particles are referred as colloidal particles. So please remember here, the colloids are colloidal particles. They are actually, okay, they are not a substance, but how we are going to define? They are going to be defined based on the size of those molecular particles. If the size of the particle is in the range of 10 raised to minus 9 meter to 10 raised to minus 6 meter, okay, then such type of particles are called colloidal particles. Okay, well, now if we consider colloidal particles, what we said? So the colloidal particles have enormous surface area per unit mass because of their size. Yes, when I consider size is very small, right? Size is very small. What is the range I said? 10 raised to minus 9. 10 raised to minus 9 to 10 raised to minus 6 meter. We know that surface area, ನಮಗೇನು ಗೊತ್ತಿದೆ? Surface area and size, how they are related? Yes, surface area and size both are, okay, both are inversely related. Yes or no? Means if size is very small, as size is very small, then what about surface area? Surface area is very high. So as both are inversely related, so we say, what is the sentence we are using here? The colloidal particles have enormous surface area per unit mass because of their very small size. Okay, if I consider the concept of colloid, well, in 1861, what's the year? In the year 1861, a scientist named Thomas Graham, okay, our scientist Thomas Graham observed that sugar, urea, sodium chloride passed through the membrane. Okay, what he observed? Thomas Graham, he observed, say, sugar particles, urea particles, sodium chloride particles, they passed through the membrane, while other particles like glue, gelatin did not. Okay, ಏನು ಅಬ್ಸರ್ವ್ ಮಾಡೋದಲ್ಲಿ? He observed sugar particles, okay, urea particles, sodium chloride particles. What happened? They readily passed through the membrane, a type of membrane. ಯಾವುದೋ ಒಂದು membrane through ಏನಾಗ್ತವೆ? They readily passed through such type of membrane. But what are the other particles? Glue particles, okay, gelatin particles, albumin particles, etc. They not passed through the membrane. So such type of particle, this type of particle he called colloids. Andre, what is the basis here? So he just analyzed a group of particles. Okay, Some of the substances, particles of substances, they are passed through membrane, and some other particles they are not passed through a membrane. The one which are not passed through membrane, those membranes he named as colloids. How can karda hu, they are named as a colloids. Okay, well, so a colloidal solution means, say if I consider sugar, urea, NaCl. What type of solution it is? It is a homogeneous mixture. Okay, it is a homogeneous mixture. But what about glue, gelatin, albumin? They are heterogeneous mixtures. Therefore, what is the conclusion we can draw here? A colloidal solution is a heterogeneous system. Okay, it is a heterogeneous system in which one substance is dispersed. Okay, one substance is dispersed as large particles in another substance. So here again, if I say colloids, what it is? Yes, it is a heterogeneous system. Okay, heterogeneous system in which one particle is dispersed in a another substance or another particles. So we say a colloidal solution is a heterogeneous system in which one substance is dispersed as a large particle in another substance. So the particles which are dispersed are called dispersed phase. You can create now dispersed phase anta kariತೀವಿ. And another substance which is named as a dispersion medium. Means, as like we say in solutions. Okay, if I consider solution is made up of how many particles? Yes, they are also made up of two type of substances. One is solute, another one is solvent, right? Solute which is present in less quantity and solvent which is present in more quantity. Similarly, if I consider colloid, yes, colloid is also made up of two type of substances. One is dispersed phase. Okay, one is dispersed phase, and what is another one? Second one is dispersion medium. So solution is homogeneous. Okay, solution is homogeneous. But what about colloid? Colloid is a heterogeneous system. So we say colloid is nothing but, yes, a colloidal solution is a heterogeneous system in which one substance is dispersed as a large particle in another substance. Okay, so here if I consider size wise, dispersed phase particles are larger in size. Okay, dispersion medium particles are smaller in size. Please make it clear. Okay, now if I consider size of the dispersed phase particle and dispersion medium particle, which size is more? Yes, dispersed phase particles are larger in size while dispersion medium particles are smaller in size. Now coming to the quantity. Okay, what is the second factor I am considering? Quantity. Quantitatively, dispersion medium particles are less in quantity, while dispersion medium particles are more in quantity. Please remember this. So if I consider size and quantity, whose size is more? Dispersion medium, sorry, dispersed phase particles are going to have larger size, and quantitatively they are less in size. Okay, well, if I consider dispersion medium, size of the particle is small but quantitatively they are present in more quantity. Okay, as like we say here, solute and solvent, the solute particles are present in less quantity while solvent particles are present in more quantity. Okay, so well, just recall the definition of colloid. What it is? A colloidal solution is a heterogeneous system in which one substance is dispersed as large particle in another substance. So yes, colloidal solution also consists of two particles or two type of substances. They are named as dispersed phase and dispersion medium. Okay, well, now if I consider heterogeneous system, what we said here, the colloidal solution is a heterogeneous system. Yes, what do you mean by heterogeneous system? Is what we said. it is going to have more than one phase. While dealing with the solution, what we said, if any mixture is going to have more than one phase, then it is named as a heterogeneous system. If they have only one phase, homogeneous. If they have more than one phase, then it is named as a heterogeneous system. Well, next thing we said, dispersed phase, right? As we said, colloidal solution contains dispersed phase and a dispersion medium. So, well, what do you mean by dispersed phase here? Yes, dispersed phase is nothing but it is a phase in which a substance exists. Substance exist as colloidal particles. Okay, dispersed phase means these are the actually colloidal particles, right? Well, another one, what we said, dispersion medium. Okay, dispersion medium ಅಂತ ಹೇಳಿದೀವಿ. Yes, what is dispersion medium? So dispersion medium is nothing but the continuous phase. It is the continuous phase in which the colloidal particles are dispersed. It is a continuous phase, okay, where colloidal particles are dispersed. And one more thing, what I can say, which is present in more in quantity. Okay, well, so terms, recall the terms, definition for colloids. Okay, it is a heterogeneous system. Meaning of heterogeneous system should be remembered. Then yes, there will be two phases. What are those? Dispersed phase and dispersion medium. Two type of substances. And meaning of dispersed phase and dispersion medium. Well, now if I consider some examples for it. So salt in water. Yes, what type of mixture it is? Is it homogeneous or heterogeneous? Can I ask, is it a colloid? Salt with the water. Okay. So answer is no. It is not a colloidal solution. Okay. Because to say colloid, what we said? To say colloid, first thing, it must be heterogeneous. In NPTEL, as I said, colloids are heterogeneous system. Okay, a colloidal solution is a heterogeneous system in which one particle is dispersed as a large particle in the another substance. One substance is dispersed in another. So first thing, to say colloid, it must be heterogeneous and particle size. What is the particle size? 10 raised to minus 9 to 10 raised to minus 6 meter. Okay, these two criteria must be there to say colloid. Now if I consider salt in water, salt with water. So salt with water, what it is? It is a homogeneous mixture, right? It is a homogeneous mixture. Then it is not fulfilled the condition. Then I cannot say it is a colloid. But rather the salt in water is an example, well-known example for true solution. Okay, well. Now one more example, if I consider milk, can I say milk as a colloid? Yes, is milk form a colloidal state? Answer is yes. Yes, milk is a well-known example for colloid. Why we are saying milk is a means, say milk is a example of a colloid because here protein particles, okay, whatever the protein particles dispersed in water content, they fulfill both the criteria. Yes, it is a heterogeneous mixture and here particles are lies in the range of 10 raised to minus 9 to 10 raised to minus 6 meter. Therefore, milk becomes an example for a colloid. Okay, well, one more example, if I consider sand in water, sand with water. Sand, what about particle size here? Will be greater, okay, larger size. And whether it is homogeneous or heterogeneous, it is a heterogeneous mixture, right? Though it is heterogeneous mixture, but what about particle size? Okay, particle size is very large. It won't fit into this criteria. Therefore, I can say sand with water is not an example for, it is not an example for colloid, but is an example for what? Is an example for suspension. Navin Karitivi, sand in water is an example for suspension. Here particle size are greater than 1000 nanometer. Okay, well, what is the difference among true solution, colloidal solution and suspension? Yes, we come across three examples and they are going to form three type of solutions. What are those? True solutions, colloidal solutions and suspensions. Yes, how we can distinguish these three? Solution, okay, true solution. What is the size of the particle? Will be less than 1 nanometer. Okay, true solution anta bandre here size of the particle will be less than 1 nanometer. And what about nature? It is a homogeneous. Okay, just I will consider two criteria. Second thing, if I consider colloids, okay, colloidal particle, what is the size here? 1 nanometer to 1000 nanometer. Here size of the particle is in the range of 1 nanometer to 1 nanometer to 1000 nanometer. And what type of solution it is? Yes, it is a heterogeneous. Okay, colloidal solutions are a heterogeneous mixtures. And the third one, what we said, suspension, their size of the particle will be greater than 1000 nanometer, and it is also a heterogeneous. Okay, it is also heterogeneous system. Now here, when you look at the particle size, okay, when you look at the particle size, how they differ from one another? Yes, the basic difference rises. It is because of, it is due to, due to different size of particles, in a dispersed phase. So how they differ from one another means true solutions, colloidal solution and suspensions, yes, they differ from one another only because of size of the particle is different. So true solutions, size of the particle is less than 1 nanometer, while colloidal solutions, here size of the particle is in the range of 1 nanometer to 1000 nanometer, while suspensions, here size of the particle will be greater than 1000 nanometer. So as the size of the particle differs, therefore we are getting different type of solutions. Okay, well, as I said here, if the size of the particle, okay, if the size of the particle in the disc phase is in between 10 raised to minus 10 meter to 10 raised to minus 9 meter, then it is called true solutions. In you know, if the size of the particle of dispersed phase is between 10 raised to minus 10 to 10 raised to minus 9 meter, or second say generally I said less than 1 nanometer. So if it is in the range of 10 raised to minus 10 to 10 raised to minus 9 meter, then it is called true solutions. Okay. Then example, as I said, salt in water is a well-known example for true solutions. Okay. Well, then the particle size of dispersed phase is between 10 raised to minus 9 meter, 10 raised to minus 9 meter to 10 raised to minus 6 meter. Then such type of solutions are called colloidal solutions. So what is a well-known example I said? Yes, milk is an example for a colloidal solution. Then next one, if size of the particle, size of the dispersed phase particle is below 10 raised to minus 6 meter, okay, below 10 raised to minus 6 meter, I can say more than 1000 nanometer, then it is called suspension. Okay, well, what is the example? Sand with the water is an example for a suspension. So three types, as you said, true solutions, colloidal solutions and suspensions. Yes, they differ from one another. It is because of size of the dispersed phase particles. Okay, well, now coming to the MCQs. Well, the first one, colloids have the molecular size range between. So if I consider colloidal particles, what is the size of the particles, which is lies in the between? First option, 10 raised to minus 9 meter to 10 raised to minus 2 meter. Second, 10 raised to minus 9 to 10 raised to minus 3 meter. Third, 10 raised to minus 9 to 10 raised to minus 5 meter. And the fourth one, 10 raised to minus 9 to 10 raised to minus 6 meter. Yes, what is the answer here? D is the right choice. 10 raised to minus 9 meter to 10 raised to minus 6 meter. Okay. Well, next, colloids are A option, homogeneous system, heterogeneous system, okay, both, none of these. Yes, what is the answer? Yes, colloids are homogeneous and heterogeneous. Yes, they are a heterogeneous system. Okay, well, with this, I'm going to conclude about this session. Again, in the next session, we continue the remaining part of the chapter. Okay, thank you. Be safe.